Hello students, welcome to my channel. Today we are going to start one important topic called as indicator diagram for thermodynamics process. So indicator diagram of thermodynamics process is our next topic, student. It is very important section. Let's say that we have basically pressure, volume and temperatures are the thermodynamics indicators. So initial states, let's take the initial state S1. From this, our thermodynamics process changes to P2, V2 and T2. Now student, from here to here, from S1 state to S2 states, if a process is changing, there can be an infinite number of ways. If I represent it in PV diagrams, this side I have taken it P and this side I have taken it V. Initial section I have taken it S1 and final section I have taken it S2. So from S1 to S2, I can have infinite number of ways to go. So all the infinite number of ways are called as thermodynamics process. So generally in our section we discuss four process called as isochoric process. All of you know all this, that isochoric process where volume is constant. So if my volume is constant, from this is my first step, isochoric. I can go it from isobaric process also. So in isobaric, my pressure will be constant. So this is my isobaric process, student. Next process, I can go it by isothermal also. So isothermal, I will take this one will be the isothermal process. And next, it can be adiabatic. And this one is the adiabatic process. So from S1 state to S2 state, if I move it, I can move it by infinite number of ways, and every ways have been a specific thermodynamics process. So work done by the gas, whenever we move, we take the work done by gas as a positive. Always keep in mind that whenever work is done on the gas, so it means that the gas is expanding here and this will be positive. Whenever work is done on the gas, it means that we are compressing the gas, and work done when we are compressing it, it will be negative. So if we take this sign convention in a PV diagram, if we are representing the work done process, student, work done, if I am plotting it from initial to final state, the area under this plot will be called as work done by the gas. So in a PV diagram, area under this plot will be called as work done. Now sometimes what is also given, in just to confuse the student, this VP plot is given. So whenever we have VP plot like this, remember that student, we will take this area with y-axis. This will be my work done. Okay. So area under the graph is there, but which section you have to take? If it is a PV graph, we will take it in under the X section. If it is VP graph, will take under the Y section. So these are the important key component that you have to keep it in mind. So for isochoric process, this is the process where volume is constant. For isobaric process, where pressure is constant. So this is my isobaric process, student, right? Next is isothermal process. So isothermal is this process, and next is adiabatic process. And as you know, adiabatic is a process in which no heat is exchanged. So for isothermal, we are getting the graph as P is directly proportional to 1 by V. So if you plot the graph, we will get a graph like this. Okay. So P is directly proportional to 1 by V. Graph will be like this. So this is an important section to take care in mind, and already we will discuss all this isochoric, isobaric and isothermal adiabatic process in detail. But I want you to understand that if I take one state to another state, there are infinite number of ways. Any number of ways can be there from reaching from one state to another state. Basically, generally we take four general component which thermodynamics process in our study. The other will be polytropic process. Depending upon the gamma, it can change. So this next section, if you take here, PV to the power gamma is constant. You know this is for adiabatic process, right? PV to the power gamma is constant. This is gamma is the adiabatic constant. Now, if this gamma value is changing, based on this gamma value, I can have any number of gas equation, right? So gamma range can be varied. So gamma is variable, and based on this gamma variable, I can have any number of this polytropic process. So PV to the power C if I take, this will be called as polytropic process. Okay, so that's why I am saying that there are infinite number of ways. PV to the power gamma, this is adiabatic process. Okay, now if I take, instead of this gamma, if I take any C value of this will be a polytropic process. So that's why when we are going from one state, from S1 to reach to another state, I can have any number of this process. Okay, based on our requirement, I can go from here to here also like this, I can go from here to here also like this. So based on this, I can have infinite number of process. So let's move to the next section now. Now the standard thermodynamics process, if I take in our study, and by first law of thermodynamics we can write it as delta Q is equals to delta U plus delta W. This is what I can write from the first law of thermodynamics. So if I have a PV plot like this, I move from initial to final position. So initial to final position, if my volume is constant, so you know that area under this curve is nothing, so area under curve is 0, so that's why work done will be 0. So if you apply the first law of thermodynamics here, student, Q will be equals to delta U, and it can be written as NCV delta T. Q will be equals to delta U, and it can be written as NCV delta T. Now you know that CV can be written as R by gamma minus 1. So we can also write this as NR by gamma minus 1 T2 minus T1. So just to make the summary of all this, we are doing this in combined loop. Now the next one is, this was our first, next one is isobaric process. So in isobaric process, my dear student, the pressure is constant. So pressure is constant. If I take this one, this pressure constant graph will be this one. So pressure is constant, volume is changing. So work done will be NR T2 minus T1. Work done will be NR T2 minus T1. And if I write in terms of V2 and V1, it will be P V2 minus V1. So work done, these two are the important formulas which you have to take care when isobaric process is there. Now, if you write in terms of Q, so Q will be equals to NCP delta T, and this Cp can be written as R by gamma minus 1, so it becomes N gamma R by gamma minus 1 T2 minus T1. Again important sections we'll discuss. Next we are going to discuss the questions based on this. So again important section which you have to take care, student. So delta U will be NCV delta T, and it can be written as NR by gamma minus 1. So we got W, we got Q, we got U. Okay, so take care of all this when you are reading the isobaric process. Next section which we take is an isothermal process. An isothermal process, PV is equals to constant, T is constant here. So when for such section we will take Q will be equals to W, Q will be equals to W here, and we can write it as NR log V2 by V1. And if I want to write in terms of pressure, my dear student, we can write it as NR log P1 by P2, because here PV I have inverse relationship, so V2 by V1 will turn into P1 by P2. So be careful on this part also. This is also an important section. So our whatever heat supplied, that will be, whatever will be the work done, that will be the total heat supplied here, and this will be equals to NR log V2 by V1. Next section, student, the fourth one for the standard thermodynamics process, we are taking it as adiabatic process. PV to the power gamma is equals to constant. Here Q is 0. Here temperature was constant, here Q is 0. No heat is supplied. So no heat is supplied. The graph which we will be plotting will be like this. PV to the PV gamma is equals to constant. This is the graph. So work done, student, will be equals to minus delta U. And if you see here, it will be minus NCV delta T. I hope you understand here. So CV again we have written it in R by gamma minus 1, and this become one of the standard result for adiabatic process, which will help you to solve many questions on this topic. So combine, I have just given you idea of all the process. Just these are the only section, none of the question will be out of these sections, which we will take care into this. So next section which we are going to take is one question here. 1 mole of a gas expand obeying the relationship PV diagram. So I have a PV diagram and a gas is expanding from V0 P0 to 2 V0 P0 by 2. Okay, PV diagram is given. Student, you have to calculate here the maximum temperature. So if you have to calculate the maximum temperature, we know that for ideal gas, PV is equals to nRT, and we have P0, V0 given, so I can calculate the temperature. So if T I have to calculate, it will be PV by nR. Number of moles, this becomes the standard formula for finding temperature. If I have to find the temperature at A, so I'll put the pressure at A, this point is my A point and this point I take at B point. So pressure at A will be equals to P0 V0 by N is 1, so P0 V0 by R. This becomes the temperature at A. So temperature at A is P0 V0 by NR, my dear student. Now I tell you one important tricks here. So if for any 2 points, if my temperature is same and I have to calculate the maximum temperature can be given out by P average V average by NR. This is the standard result which you can use here to calculate as a trick. So this few tricks we are going to study on this. This is an important trick to calculate the Tmax whenever for any 2 points in a PV diagram, if my temperature is same. So I can apply P average, V average by NR. So let's check here whether the temperature here at B is also P0, V0 by R. So I'll use this result. Temperature at B will be given by P0 by 2 into 2 V0 by N is 1 and 2 R. So if you simplify this here, 2 will cancel out here, and again we are getting the temperature at V as P0 V0 by R. So temperature at B, my dear student, is again coming P0 V0 by R. So both the temperature are same here. So I can apply here the Tmax is equals to P average by V average. So let's see how we have to apply it here. So if I apply here the Tmax here, so P average will be P0 plus P0 by 2. This become my P average, and similarly I have to write it for V average. So V average will become V0 plus 2 V0 by 2. This become P average, this become V average by NR. N is 1, so I will take 1 into R. Okay, this is my Tmax, my dear student. So if you simplify this, what is this coming? P0 plus P0 by 2. So P0 plus P0 by 2 will be 3 P0 by 2, and here I have this one. So if you simplify this, Tmax will be coming here as 9 P0 V0 by 8R, and that will be my answer of this question here, student. Okay, so this is how we got the answer. So these are the tricks which we are going to learn in our upcoming sections. Thermodynamics process, all the process we have taken care, and we are taking all this, the tricks which will help you to solve the questions in your mains and JEE level. So that's all for today, my dear students. We'll connect very soon. So that's all for today. Thank you.